Theo, an architect, co-founder of LASSA, an architecture office which is based both in Brussels and London, I think. And Theo is going to show us some of his latest projects using CNC machine and well, new ways to build houses from Brussels to Greece, for instance. Theo, up to you.
Good evening, everybody. I'm Theo Lalis, and together with Doris Wade, who's just there, we founded LASSA about 5 years ago. We operate from 2 offices. Our main office is in London, and we have a second office here in Brussels, where we actually have a CNC machine and a fab lab, and we do more experimental work with digital fabrication installations, but also buildings. So we currently have we're currently also involved in a series of large projects in Asia and Kuwait. And concurrently with the practice, we also teach at the Architecture Association in London. We also run a series of workshops and do installations worldwide in places such as Rio, Korea, and China. Now, our current research focuses on the role of form within spaces of knowledge exchange in the age of digital content, and most importantly, outside of institutional boundaries. So, how do we exchange knowledge outside of libraries with dematerialized content? And we're particularly interested in the idea of producing architectural form and tectonic systems that integrate multiple design objectives, such as this example where structure, acoustics, and the spatial experience, and probably religious coding, are integrated into one form. So instead of using separate architectural elements to fulfill different functions, then one form we can integrate all of that. And we can develop that with a computer nowadays. We're also very much interested in the performative aspects of form and their capacity to materialize relational spaces, and more particularly repositioning the body in society through action and the triggering of senses. So we're very much interested in participative art, such as Lydia Clark and some of the installations of Sarah Seno that we use as inspiration for our projects. And today I'm going to present two projects of our Brussels studio. I will start with a small nursery that we're currently prototyping and about to construct here in Brussels. And what's interesting about those 2 projects is that we had been involved in the past in designing our projects in 3D and having them manufactured by digitally, like file to production by shipyards and aerospace companies or the car industry. But now, what's particularly interesting with those projects is that we are able to design and construct buildings in our basement. So it's basically desktop manufacturing, but not at the scale of small laser cut models, but actual usable buildings. And the interesting thing about that is that we can also, because we have managed to survive a series of important constraints such as cost, we are also able to gain a lot more creativity that our profession is lacking sometimes because of budgets and other restrictions that we have. So the first project I'm going to show you is a collaboration with Y Architects, Yannick Deneyer, that you can meet later as well. And we were invited basically to develop a small prototype for a nursery. It's basically a classroom that we would have to design and manufacture in-house and self-construct. And we had only the thickness of the wall to basically be creative. The outside envelope was constrained by a building permit, and the inside area was constrained by ONA, and so that gave birth to a series of interesting creative possibilities. We developed the project like a Swiss knife, so basically the structure of the building is also furniture, so it contains function, and we were able to integrate all sorts of basically interactive parts, such as this window with the shutters, but we also had libraries, tables popping out of the wall, and this is visualization of how it could be, also when things are closed. So the idea was also that the children could interact with the building. The functions integrated in the wall were ranging from storage to educational functions such as climbing, but also other functions of the daily routine of eating and reading and playing and so forth. So basically, we cut a mock-up in our studio, and we assembled it ourselves with the help of a contractor as well. Basically, we assembled this in 45 minutes, which by figuring out all sorts of problems, all sorts of constraints, and we figured that we could probably build the whole nursery we could pre-assemble it in 4 days and assemble it in 1 day on site. So you can see here the cutting, then the pre-assembly, 45 minutes for each shelf. Then everything gets transported and then plugged into place. The second project I'm going to show you is a project in Greece. It's located in the southern tip of Peloponnese. And we were able to explore this idea of form integration in this project, and form as a negotiated form. The constraints we worked with were primarily to basically, we were located on a hillside in an olive tree field, and we had to frame, the client requested that the house would frame this particular island and the village, which were not visible from the ground. Because of the olive trees that were planted according to the slope, the views were not framed. And so the role of the building was to reorganize viewing, both panoramic viewing and close-up viewing, in a cinematic way. And so the organization of the project was that it would be very, very slender, with a very large opening framing those views, and it would also be producing a series of hemispheres around it that could be used at different times of the day, and all of this would be connected by a green roof. So basically, an extension of the landscape. As you can see it here, movement is continuous. You can enter the house, come out, go up the roof, go down. And basically, the form of the building performs several purposes. One is to extend the landscape, just barely going at the height of the olive trees and dipping down again. By doing that, we're producing the 3 courtyards, and the extension of each cantilever of the shell is basically calculated according to how much sun we want in each courtyard. So basically, as you can see, with some simulation we did, we were able to basically organize the daily routines of the house according to lighting. So, for instance, the west courtyard would be in the shade in the morning. We would have breakfast. The east courtyard would be in the shade around noon. We would have lunch, and so forth. So basically, the activity would actually revolve around those courtyards and over the roof. And so the sleeping rooms which are there are just used for going to sleep at night. But basically the outside and the landscape is very much part of the experience of that house. We also calculated the shell so that it provides shading. Basically the light doesn't touch the large opening so that it remains cool during the summer, whereas in the winter, light would penetrate very deeply inside the living room and heat up the space. So all these things were possible to calibrate because of software simulation, basically. So basically this arch here is precisely framing the island. The east courtyard is framing that village over there, and the west one is the entrance. This is a view from the roof. And another thing that's peculiar about this house is that you wouldn't be able to see it totally as an object on the landscape, but rather you'd only experience one courtyard at a time. It's not an object, it's totally embedded within the landscape. And that's a viewpoint, the framing of that island. And on the ceiling you can see some of the features that we developed later with the CNC. So one of the big questions about this project was, how can we realize this project in a place where the construction industry is not very sophisticated? The budget is fairly low. For your information, the construction cost in Greece is not much lower than in Belgium. So basically, the main challenge we were facing was how to build this concrete shell. So basically, how we could form the shell. And so we looked into different techniques. This is a project I worked on in Ireland, where we basically used a CNC milling of large polystyrene blocks. So basically, we designed everything in 3D. We sculpted foam. We sprayed polyurethane on it, and then we poured this sculptural bridge on top, which basically was very, very efficient technique and also quite cost-effective compared to steel structures that would have been 20% more expensive. So we tried that. That was too expensive still. So we said, okay, how much does it cost? It's a third of the budget. How much does the CNC machine cost? How much wood do we need? How much time are we going to work on this? And then we said, okay, let's move our studio and let's buy a machine and let's do it ourselves. So that way we can also do the furniture. We could do all sorts of other things, the landscape. We're never going to be able to build this project with that budget if we don't buy the machine. So we started with very small, basically small-scale laser cutting tests. One of the constraints we had is we had to ship to Greece about 5,000 parts of a puzzle that we would need to assemble quite fast. We were not builders in the office, we're architects. We use computers most of the time. And so we basically looked at Chinese temples that are basically made out of connections without screws. And so we developed a system, geometrical system, where we could assemble 5,000 parts without making mistakes and without wasting time screwing, which is a huge relief for the team. By this point, our engineer dropped us, so we said it doesn't matter. We'll make a one-to-one test in the basement, and we realized it was overstable. So we hired another engineer to basically save some wood. So this took about 10 minutes to assemble downstairs. And so we also gained confidence about our ability to basically produce the formwork ourselves, which we're not very used to. I mean, all of us had used laser cutters in school and with the students, or designed stuff that is produced or laser cut by others. but this time it was us. So, and because we're a bit lazy, we said, okay, let's try to put all the intelligence in the 3D and the geometry, and also limit the amount of mistakes. A second part of the formwork was the double curved part. The one I showed you before is planar and is fairly straightforward. The other one is double curved. So we had to look at a series of strategies of how to produce the curve, but at the same time, instead of throwing the formwork away, keeping the formwork to perform something else. And we felt that in the living room, where we have double curvature, there might be a problem of echo. So basically, this structural system, which is a mock-up, also a prototype we did in the studio, would give us acoustic performance somehow. So here you can see all the carcass, all the different layers. Then came a moment where we knew what the project was, and we basically scripted all the production of the parts. So we didn't draw every fin one by one. We wrote a script using Rhino and Grasshopper, where basically all the cutting, all the production of the geometry, all the assembly, the unrolling, and even the numbering was done by this guy. It's a script that takes about a month to write, but I can tell you that it saves months of cumbersome labor. So at some point, the building started. This is our CNC machine. It's part of our basement in Saint-Gilles. So this is a 3-axis machine. We can sculpt wood or other materials up to 30 centimeters and produce molds for sculptures and things like that. And the building started getting a physical presence in our basement. This is only half of the panels. So we were wondering whether we were doing the right thing, but it was too late to go back. We had to build all sorts of parts. Although we were only producing the formwork for the ceiling, we had to produce a series of parts on the ground, which are those purple parts, so that we could design the whole geometry of the building without the use of a surveyor. So basically everything is clipped like a puzzle. Everything is numbered. There's just one insertion point for all of that. It's put together by us in a day. And then everything is very straightforward for the contractor. Also, it would enable us two levels up to fit our formwork between the walls and have no tolerance problem. So the strategy we chose was to ask the local contractor to produce a series of tables, which are there, and then we would place our formwork on top. These are the levels, so it's very, very simple to produce for anybody. It doesn't require specific knowledge of geometry to do that. This is 2 days of work, 4 people. It's actually much faster to assemble than IKEA furniture, because all of these parts slot very easily. The funny thing is, and I wouldn't have expected that, is it took much longer to produce the tables than to install our part. Actually, we actually moved to Greece for 4 months with part of the office. We had a server. We brought a A3 printer, which we never used. It was a totally paperless construction site. And we were starting work with the guys at 7 o'clock, and at noon we were on the beach fishing, or I don't know, having drinks. So it's part-time, 4 days. So here you can see all the tables. This is the double curved part of the living room, where you can see the supporting structure for those fins that you saw in the rendering. This is the formwork, which is there, and the little elements that pop out are the dowels. Basically, they're attached to the concrete, basically, the rebar. So all of this was also scripted. There's a series of panels that are super thin. They're just 6 millimeters. Like this whole part could cost something like 600 euros. So 6 millimeter top shell, which was just plugged. Everything was pre-drilled. And then, as you can see, the cables, the electricity was already there. I mean, we just had pre-drilled the electricity, so we could insert some lighting. And all of that part in the center basically was going to remain after we take the formwork out. So it would stay on the ceiling and be an integral part of the building. So these are the tools we used for our site. We used the laptop twice when we basically lost one part out of 5,000. Basically, we cut twice one piece, and we had to cut it by hand again. The other one was to cut the tables from the contractor, basically, because the tables were interfering with the formwork. As you can see, also they are numbered. So this is southeast panel 16. It's all very straightforward. But there's no manual, no drawings required. We designed it very intuitively. So at this stage, the formwork is almost ready for pouring the concrete. So basically, we're making a giant mold. These parts, the black parts, are exposed concrete. The other part there is the wood that's going to remain the ceiling. We used a series of techniques from the shipping industry or skate parks, to produce those tighter curvatures with a numerically controlled hot wire cutter. Yeah, and so that was a view of the house after the demolding. The formwork, the OSB parts are false work, so they are to be detached, and the ribs that you see in the background are that's the actual formwork that's staying on the ceiling. As you can see there, we are detaching the false work, and what's exposed is the ceiling. You can see it there. Actually, the design of the seams, which looked like dunes, came out of a constraint as well. I mean, we used all sorts of constraints in a creative way in this project. That was used to minimize the amount of wood. The panels that we buy in the market are 2.40 meters. That means we would have had a line on the project, so some kind of grid implement on this, and that would have been a real pity. So we said by curving this, then we can have smaller panels, and therefore we can put more fins in one panel. So all of you who are familiar with laser cutting, it's something that's quite handy. So we used also all sorts of software to nest, so basically to position the panels in order to save material before it's cut numerically. So we were just feeding the machine like we feed a printer, and with paper, and the machine was cutting, and then we're just stacking into piles, and then everything was numbered. So we didn't have to. We're not looking for parts. It was quite intuitive. So this is the demolding. You can see the exposed concrete. That was the black plywood, and that's what's remaining. This is the view of the island. That's the framing. And we developed all sorts of other patents for the project, like we thermoformed, so we designed a mold and thermoformed these lighting fixtures. We bought a series of LED panels in Shenzhen, in some kind of electronics mall, and we designed this small detail in-house and populated the ceiling with those little lights that we can modulate. So that's also not a very expensive detail. It probably cost something like 60 euros. But because we have the machine and we can mill the mold, we can mold all sorts of forms out of plastic or other materials. The house has a perforated facade, which is very exposed to direct sunlight, but also needs a little bit of defense from theft. So we use this pattern, which is made out of numerically cut with hot wire those polystyrene blocks. We have 3 scales, and they're all placed according to our drawing. They perform as spacer for the concrete. If you know the work of Tadao Ando, there's a series of round circles, whereas here they would perform that role, so they have also a constructive role. We design these molds also with using the CNC and bent corian to produce those frames for the windows. The glazing was water jet cut, so basically everything was done from our digital files. There was no measuring and redrawing by the construction company costs a lot of money. A friend of ours accepted to laser cut a sheet of steel for the door to extend the pattern of the facade. We recuperated some of the cutouts to produce the handles of the door. We were looking for a shower of that dimension. Actually, the ones that we found in the market were more expensive than this one. We designed, we sent our G code to a marble manufacturer, and they cut this shower that was basically flush with the floor. It was not some kind of ceramic piece that's added, but it's completely continuous with the ground. So it was also a lot more interesting conceptually. We designed all the furniture for the house, a series of tables and all the furniture basically. And then these are the photos of the completed project. It was built in 8 months. There are all sorts of interesting outcomes that you don't get out of modeling a project on the computer. Like, we looked at the sky in a very different way through the project. This is the entrance with a perforated wall and some furniture that we designed to accommodate for the uses according to the rotation of the sun, but also some night activity. This could be used as a projection wall. This is an outdoor cinema. This is the inside of the corridor, where, as you can see, there is enough light, but it's not too strong. And actually, it produces all sorts of interesting projections on that wall at a particular time of the day. So we used frameless doors so that the choreography of light could occur. Another photograph of the ceiling in the living room with those curvy seams and creases. And yes, that's a view from the roof. And that's it. Thanks a lot. I don't know if you have any questions. Probably we can discuss at the bar, or unless somebody has a question.
Can you reuse the wood for another house, or
reuse the false work or the foam work? You mean the OSB is very fragile wood. It breaks, so it's not like the moment we demolded it, it was breaking. It's not very resistant to flexion somehow. So that's all. Yeah, I would say that's a problem, I would say. But we use the most economic wood for that part, and the other one, which is plywood and more resistant, that stays in the project. I actually, no, I just want to add something. There was a question at some point, if we're going to transport that amount of wood to Greece, why not build the project out of wood, right? Entirely. There's enough wood. We probably would have had to use different type of wood and probably increase the cost. But then to get a permit in Greece, you need to use concrete. And because there are a lot of earthquakes. So it had also to be quite substantial. So the option of wood it was not an option, basically. We would have never got the permit. But if it was in Belgium, yes, we could have built that out of wood, like we are building the nursery next month, and we could have left the wood there and not waste anything.
Did you get other demand to make other house like this in Greece?
Not yet, because I'm very slow at publishing this, you know. So next month.
But the neighbors or something didn't.
No, we discussed. We are in conversation with 2 clients, and we have actually 2 more commissions in Belgium that I haven't shown you. 1 for Conservatoire and possibly 2 more with. That we're doing in collaboration with Y. So.
Yeah. Okay.
I have a question about the status of your work going from architect to builders, or at least a hybrid. Do you think it's like a new work? A new métier, a new way to build, to be like more hybrid?
Well, to be honest with you, with the internet, we've already accepted to be travel agents, publishers. There's all sorts of roles we perform thanks to this guy. And so it was not a very big step to say, okay, let's try this out. In any case, we would have had a lot of obstacles in our creativity if we didn't for those projects. For the larger projects, I would say it's a bit different, but especially for those smaller commissions where the budgets are very tight, we actually have no problem. Actually, a lot of artists produce things with their hands, and actually it's as much as we love and we're geeks in using the computer, we also like the physical outcome of all the creative activities we have in the digital world. So actually it's very rewarding to be able to design something and to manufacture it in the basement almost the same day, test an idea. In some of the prototypes I showed you, we had the idea in the morning, we modeled it, we cut it, we hang it on the ceiling, and we called the client for a review. And then it happened very, very spontaneously. We can also outsource the cutting. The assembly is just like a workshop somehow. I mean, the nursery is probably maximum a week of work, and the house was also like 7 days part-time. So it's not like, but the difference with the builders is that we put put everything in the digital file. We have no skills. We're not trained to do those things apart from assembling puzzles, and so basically we spend a lot of time modeling and or writing code for scripting our geometries. And but what's the most interesting thing is the prototyping in the office, I think. Let's say Greece is probably as far as we can stretch, but we've also been contacted by a client in Uruguay, and we would just email the cut files to a CNC workshop there, and then just take a flight with 2 guys from the office and just show up for the assembly. But we would do the same for installations, wouldn't we? I mean, so it's not. Yeah, you're right. It's a change. It's a change in the profession somehow. And actually the legislation is not up to speed. It hasn't integrated all those changes yet that, you know, the smartphone and all those technologies have generated.
Suppose I would have a little hill somewhere and I would like you to copy-paste this house. How much would it cost me?
We'll discuss it at the bar. I can give you the price per square meter if you want, and then you can figure out the maths. I'm not supposed to give the budget away, but it was 1,500 square meters. So for those of you who've done a renovation or something, you probably find that reasonable. But we, like, let's say for the CNC marble, if we gave the drawings to the fabricator, it would probably cost 3,000 euros, right? Because what they would do is they would model the production files and then cut it. Whereas we just email the G code. We emailed them a file that their machine can read. So the brush went down to 700. Because the marble is produced in Greece, a local material. Concrete also is produced in Greece. So by basically going deeper in the design process and understanding how those machines and robots work, and producing the right files that are readable by those machines, then you can customize things and design things in a much more specific way. And one of the problems with architecture today, and that was one of the statements of this year's Biennale, was that the last century basically destroyed craftsmanship, and basically the industrialization produced standardization in the profession. Also, there's all sorts of norms that we have to comply with that basically reduce tremendously our creativity. And we actually disagree with that statement. It may apply to corporate firms, but we can escape standardization if we draw more and we're more knowledgeably and we're more competent in geometry. I mean, the machines are there, and yes, there are some parts. For example, the window frames and things like that, they're extruded aluminum profiles. But for large-scale projects, for example, that's also doable. Like we're designing a tower in China, and because of the scale of the building, we are able to design variation. Like not every floor is the same. The floor plates are not square; they're curved, but they're all done with flat panels. So our knowledge of geometry allows us to customize. But at the small scale, you can't customize frames, and it's actually it would produce all sorts of discomfort. I mean, there are some benefits to some of these industrial products, but yeah. Yeah, I actually regret we didn't do the door handles. You're right, like Adolf Loos and Wittgenstein. That's we left it for next year because we're a bit exhausted. But that's also doable with 3D printing and wax. We're discussing about 3D printing wax and molding then becomes a total project. But yeah, it's also finding a limit to what is exhausting and excessive and what's enough. So